Micheal EA7KIR was first licensed as G8WAA after working in commercial TV production for many years. Now he's living in the Costa del Sol and building up a digital ATV station for QO100. We're now going to show you a video which Micheal has made showing the development and operation of his Mac-based desktop controller for his QO100 station, and then he'll be joining us live to take your questions. So please ask them on Zoom and BATC during the film, and don't forget to include your name and your call sign if you have one.
I'm going to demonstrate some software I'm writing for QO100. Now, I only discovered DATV over satellite a few months ago, so why would I want to do that? I spent my entire working life in broadcast production and post-production, but never the transmission side of things. So I bought a Raspberry Pi and a 7-inch LCD and installed ports down. But then what? What hardware should I choose? What is FEC? MUR? Symbol rate? Yes, there's tons of information out there, but for a newbie, it's very hard to join the dots. Write my own software and figure it out as I go. And why not? Let's call it the top-down approach. I'll start at the end. It's a clip I captured the other day, just in case nothing much is going on later. Okay, so there's not much here either, but wait and train your eyes on the spectrum. The orange colour along the top of the beacon indicates, well, the top of the beacon. The signal on channel 19 is therefore safe because it's in the green. Oops, there it goes. This signal is safe, but it's on the wrong channel for the bandwidth it's taking. Notice the beacon level is about 9 dB. Now see this. The orange turns to red, making it obvious for when a signal is breaking the rules. Naughty, naughty. And the beacon has dropped to 8 dB. And so has the threshold where the green turns to orange. And then it's back up to -9. Are you impressed? Because I am. That's enough for now. I'll go through all the buttons and functions immediately after the obligatory slideshow. Hold tight. I'll try and get through it as quick as I can. Honest. Unfortunately, there's not many people doing television in Malaga, so DATV over Oscar 100 is my only option. But I do have an apartment. It's a penthouse apartment, so it's got a nice roof terrace, which is where I want to put the transmitter and receiver close to the dish. I want to control and monitor it from a single GUI. I want to be creative and learn the hard way. Now, I do like being creative. For some strange reason, I always seem to choose the hard way. So KISS and RTFM don't apply. KISS, keep it simple, stupid. And RTFM, well, you're going to have to look that one up if you don't know what it means, but you really should. So what is this software supposed to do? Well, I've got an office and it's got 230 volts and an Ethernet connection going in. I've got a roof terrace, which is very nice. And that's got 230 volts as well, so that's pretty handy. So all I've got to do is lay in a single Ethernet cable to connect the two together. Easy peasy. Okay, so the internet comes into the office from the router into an Ethernet switch, into the Apple iMac running OBS and the SAP controller software, which I'm going to demonstrate to you. Also feeds an Apple TV running VNC. Yes, this is an Apple house, sorry about that. Then of course there's the new cable going up to the roof into an Ethernet switch, just a small one, which then goes on to the Pluto, the receiver and the Raspberry Pi server. Perhaps this explains things a little bit better. On the left we've got what we just talked about with the office coming into an Ethernet switch, and the Raspberry Pi server has another function to which GPIO or I2C interface, or maybe even Ethernet, who knows, to control things like power supplies, cooling fans and sensors, temperature sensors. I'm going to put a humidity sensor in as well because it rains here sometimes, and when it rains, it rains. Basically, this is what we have. It's a network. On the bottom left, we've got spectrum feed coming in from Goonhilly over the internet. working anti-clockwise. We've got the iMac SAP controller and OBS, Apple TV with VNC, the receiver, Raspberry Pi, and the Pluto transmitter. Everything connected to everything, which means anything can talk to anything. Of course, that wouldn't necessarily be what we want, but it's possible. So we finish up with the switch, server, transmitter, receiver, possible PA driver, final PA, power supplies, cooling fans, and all this has to fit into one IP66 electrical enclosure made of steel, which just happens to be highly conductive. So one RCD breaker to protect myself and anybody that happens to be passing by, followed by some MCDs that will cut out if there's any kind of a overload from any of the power supplies. The 5-volt power supply will be on 24/7, otherwise the server and the Ethernet switch wouldn't work. The Pluto, we could have a little relay to switch that on and off. The same for the receiver. And anyone who hasn't fallen asleep by now may have noticed that the relays would probably work much better if they were powered from somewhere else, such as the 5-volt supply, which is always on. So what to choose for this project? Well, BASIC was pretty good in its day. I loved Modular 2 and Pascal and things like that. I like object-oriented programming. C++, very difficult. That uses cursors, of course. No good today, but great on a 2480 display. Python, Tinker, WX Python, whatever. Now, I started this project with Python and I got a prototype going very, very quickly. In less than an hour, I had the server talking to the client and, toggling a relay. Nothing complicated, but very easy, very easy. But I thought the user interface looked a little bit 1970s. So I decided to look at what Apple do. And it turns out there's a new language called Swift, which is now open source, along with something called Swift NIO, Network In-Out. And it's really a replacement for sockets with a different learning curve. So for the user interface, the natural choice is Swift UI. You don't have to use that, but I did. Maybe a mistake because it's early days. It's not open source, it's proprietary, but they open source the other one, so maybe they'll open source the UI one as well in time. I hope they do. Okay, enough of that. And I hope you're still with me. Now, the moment we've all been waiting for. I should mention at this point that I don't even have a dish at the moment. I got one of these things, and I got one of these, but it's only just arrived. The server is kind of simulating the hardware. The server responds to requests from the client, which is running on the desktop, and here it is. At the very top of the screen, I've got the name of the program and a status bar, not really used at the moment. Over here, I've got my call sign, which is entered into the application's preferences pane. Got the spectrum display. As it looks at the moment is a lot of markers, which was helpful when I was developing to try and get the buttons lined up with exact frequencies. These are buttons, by the way. Down here we've got system control. You can see the server temperature and fans and power supplies. The receiver, it says BAT there, but it might be RIDE, I don't know. It's difficult to decide. Over here, we've got the transmitter, which is definitely a Pluto because I've already bought it. So let's connect to the network. The run button is temporary. It helps in development. Okay, it works. So we've got the spectrum display, obviously. That's the eye catch, isn't it? Oh, look at him. He's a bit over the top. So what can we do? Well, first of all, we need to turn on the power supplies, I suppose. So let's turn on. You'll notice the 5-volt, that's on all the time. And by the way, all the numbers you see here, over here, over here, it's garbage because there is no hardware connected to the server. The server talks to everything, but everything is in customs or I haven't built it yet. So this is just test data, random numbers. So we'll switch on the power supply. There's a 12 volt one and a 28 volt one. Okay. Voltage and current. Voltage and current. The server has its own fan that runs all the time because the 5 volts is on all the time, and that's driving the server. So we switch all the fans on. Intake, extract, that's for the enclosure. So the enclosure measures humidity and temperature. The only data on here that's real is this one. This is the Raspberry Pi temperature. Everything else is random numbers, so please understand that. This is the only thing that's actually correct. Right, so what can we do? Well, look, here's a signal here now. We're in simplex mode. So if I click this looks like sort of wideband, so we click that, okay? And now you'll see that the receiver and the transmitter have changed to channel 19, wideband. So it's come up on 333, which we hope is what we're going to transmit on. There's another one there. He's a bit off frequency, but let's click on him. Goodness knows what he is. You see, this is the thing. People aren't following the band plan correctly, are they? So I might have to rethink some of this. But at the moment, we're on very narrow channels at the moment. Okay, and you'll see down here the symbol rate has changed to 125. And if I want to increase the symbol rate, I can't. But I can go down. 66. 33, 25. So that prevents me from violating the rules, because the rules do say that you must use this amount of, these are the symbol rates to use it on a particular band. So it's the same with with everything else, or it will be when I discover at the moment, you can take the FEC to whatever you want. When I discover what the practical values for those are, I can also restrict that to make it automatic. Okay, so maybe I'll have to put an override in, put another button in, so you can actually override the expected usage. So here's one over here, channel 9, and now it's gone to 33, okay? We can change the mode, so there's only 2 modes, S1 and S2. We can go through these. You'll notice there's a delay when I press the button. This is because the software is polling the server every half second. I could make it go faster, but at the moment I've got it at half a second. So when you click a button, it sends a signal to the server and the answer comes back half a second later. What this means is that all the data, all the settings, everything is stored on the server, not on the desktop. That means that if you lose the connection to the server, like that, okay, or close the program down, which effectively is what I've done, and then you go back to it at a later time and you connect to the server, all the settings come back as they were, so long as the server carries on running, and that's why it's on 24/7. So you'll notice that has actually come back to what I set it to. I do a reset, now we're back to the reset values. Okay. Same with the receiver. As you see, the receiver is on channel 21 over here, which is the default value. If I go to channel 3 over here, and if the auto, right, okay, auto, let's put it into manual, right, 33. So I can, for development purposes, and because there's no receiver actually connected, I've fixed it so that when it's in auto, it gives me 3 question marks. That's not an error. That's intentional for development purposes. But in manual mode, we can actually override whatever the receiver might want to do, and we can set it to something else. So basically that's it, but I'll go through now other things. As I understand it, the receiver, will return all this kind of stuff from it: mode, constellation, FEC, and so on, which is what I see, null packets, and the call sign of whoever you're receiving, assuming that they are encoding it. So I keep talking about changing channels. So we're in simplex mode, and as you've seen, if I press any button along here on the frequency, it changes the received frequency and the transmitter frequency. So let's go into simplex mode. Now, this means that we can have different frequencies for the receiver and the transmitter. So if I want to change the frequency of the transmitter, I click on transmit, and now you'll notice this has gone to green and that's gone to white. So click there. Okay, I'll do that again. Watch the transmitter frequency and watch that, the receive. I'm only clicking the transmit, so only the transmit changes. Okay, for the receiver, at the moment it's on 3. Let's put it on 5. Okay, now it's on 5. Now, this is where it gets clever. Let's say I just want it to watch the beacon. Click beacon. Okay, so the receiver's changed over to beacon. If we take the auto off, we'll see that it's coming up with what it should do. And the transmitter, it's impossible to transmit because there's no frequency and the transmit button is disabled. Now if I go back, if I click the beacon button again, or just click anything really, but I click the beacon button, everything goes back to where it was. Okay? So whatever settings you've got, any of these settings over here, and you go to beacon and then back again, these settings will be returned. The settings are stored in a separate memory on the computer, on the server. Okay. Now there's also a store and recall. So let's, if you can remember this, we've got 5 and 9, and whatever's in here, let's put some different values in here. Oh, the drive level, yeah. Let's increase the drive level because this is quite useful, isn't it? So we've got these setups. I won't remember them, but you might. If I press store, then that's in a little store. Okay. Now I can go to beacon. I can go back to duplex, simplex, whatever you want. Change. Okay, so they're both on 9 and 19 now. And then I press recall, and it does exactly what you expect it to do. It's gone back to 5 and 9. Well, that's a number to remember. And so all these things. So there's like 2 temporary stores on the server. One to remember the previous settings that you had over here or there, and the other one as a temporary memory. A lot of activity today, and we're getting good examples of the overshoots as well, which is quite nice. And as I said earlier, the threshold level where the orange is always follows the top of the beacon, where whatever level it is at, and it's just below 8 at the moment. But normally it's about 9, isn't it? Okay, so that goes up and down, which means, of course, if you've got 3 very wideband signals going on, the beacon might, I don't know, I've never seen it, but maybe it comes down to 7. I don't know. But so will the colours. So let's say we want to transmit. Let's just go back to simplex. Channel 15. Okay, so they're both on 15 now. And I can press transmit button. So that goes transmit. And notice that whilst I'm in transmit, if I click on change frequency, whatever, it disables the transmit. I'll do that again. Okay, we're transmitting on 13, right, right across somebody else. And if I change to a different one, transmit goes off. Same with all of these. I don't know if that's necessary at the moment. Not the power though. The drive level, you can change that. But if I changed FEC, it disables transmit. I'm not sure if that's necessary. I can change that. So that's about it, I think. What else can you do? I mentioned shutdown. That's not working at the moment properly. But what else? Well, we did all that with the power supplies off. But as I said, there's nothing connected. So you can do anything you want over here, and all you're going to do is switch off and on the random numbers coming back. And of course, none of these are actually changing. Oh, I've put a random number in for packets, which is utter garbage, of course, because the number of packets would only increase, wouldn't it? These are all random numbers. Not random, these are just fixed, just so I can see the display. I think that covers it. So if we did want to shut down, I'll press the shutdown button and I think it's about to crash at this point. So what happens? Continue. This will switch off everything, followed in an orderly shutdown. Now that's the plan. The plan is it would, shut down the Pluto, shut down the receiver, and then switch off as many power supplies as it can, and then shut down the server itself and switch its own power off. Now, how the heck you switch it back on again, I have absolutely no idea at the moment, but a delayed relay for switch off might do the trick. Now, I don't think this is going to work. Continue. Nah. Okay. More work to do. Not to mention metalwork and things. I must say, learning a new computer language can be fun. It's easy to start with, but then it gets harder. But then, all languages have many things in common. Let me show you. Well, if we look at the response, we can see that we can send these enumerated values. That means turn on the transmitter fan, change the transmitter mode, and so on and so forth. Okay? The response looks something like this. We get back the beacon mode, various things, temperatures, humidity. These are just default values. Fans, intake fans, and so on. If we look at content view, this is the main view. This is the view that contains every other view. So it's a view with lots of little views inside it. For example, this part calls the spectrum control, the view. System control, receiver control, and so on. Let's look at the transmitter. Okay, final PA, temperature. So it reads the value coming in and prints it with a text thing on the screen. Press to talk, a button. This is the button for press to talk. All it does, it asks for an action and it sends a request. The action is transmitter, press to talk. And it sends a call sign because that's the way it's working at the moment. And it's the same with system control, for example. Here's a button to turn on the 12-volt supply. So request, action, power supply, 12 volt. And that's the message it sends. Coming back, we get the status. So it prints the status, it's either on or it's off. And there's the voltage and the current coming back. SwiftUI is kind of conceptual. You declare what you want the user interface to look like, and the compiler figures out how to make it work, leaving you in the dark when things go wrong. Of course, the server doesn't have a user interface and it doesn't run on the desktop. First, we need to open a terminal and log into the Pi. Type in the username and the password. Clear the screen and let's see what we've got in our home directory. SAT server is the one we're looking for. The satserver.service is something for later. And this is what a Swift package looks like. There's the license, packages resolved, package Swift, which is where we define what kind of program it is, a README file, and 2 folders, one called sources, which is the one we're going to look in now. And in here we'll find another directory with the same name. And this is where the source files are. Several .swift ones, main, request handler, system control, blah, blah, blah. To compile and run, we have to go back to the original directory, the original folder called SAT server. So let's do that. And then we just type Swift run. If it needs compiling, it will. If not, it will just run it. This is great for development because I can stop and start it at will. But if we want it to run automatically when the Pi boots, that's what the .services file was for. And that will go in a system directory and be called every time the system starts. And of course it pops up in the Finder. Click on Pi there, Pi, SAT server, sources, SAT server again. There's a source code. It's a source code. More source code there, receiver, blah, 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 and so on. Band plan. There's the band plan. Okay. Well, it will be when you get past the things. It's all in there somewhere. And to go back to the package itself. Double click on the package, like so. Hit trust and open. And we're off. And it looks pretty much the same here. We've got the same files and so on that we saw in the Finder and on the terminal. There's the band plan with the transmit frequencies and the receive frequencies. Here's the request API, which is exactly the same as we saw before. The response API. So the request handler, this is where the action happens. The request comes in, switches on the action. Status calls system control read status, and that's the one that gets polled every half second. System control toggle 12 volt supply. Press to talk, here we are, press to talk. Calls the transmitter, toggle press to talk. So let's look at the definition for that. Jump to definition. Toggle press to talk. Engages the transmitter or disengages it. Simple. Well, that's it, folks. Thank you for staying with me. And I do hope you found it interesting. And I'll be very glad to answer any questions you may have. If not, bye-bye for now.
And now Michael joins us live from what I imagine must be sunny Spain. Welcome to Cat 21, Michael, and thank you very much for making that video.
Yeah, thank you. It's the sun's shining again.
We actually... Sorry.
The sun's shining again. Yes, I was going to pass this off as live, but obviously you can't because people could be watching the stream and they'd notice the band plan. The spectrum was slightly different, and of course it could have been cloudy today, and it was sunny when I recorded, and I'm running on natural light at the moment. So.
I think the trouble is, in this hobby of all, television, we're not going to get away with things like that, are we? So, no, but I can understand because there was a lot to show there, and it was great that you did a video. I think that helped technically. It helped both of us, didn't it?
I really planned to do the whole damn thing live. You know, I set up a keynote presentation. Keynote, by the way, for people that use Windows, is like, I can't remember what it's called now, whatever it is.
PowerPoint,
yeah. But keynote is just the same, really. And it was so complicated, trying to change slides, operating OBS, because I was going to feed OBS through Zoom, you know, and then trying to remember what I'm supposed to say, and I've got verbal diarrhea, so, you know, I mean, there was no chance. There was no chance.
Problem. Well, anyway, it was great, Michael, but it's good that you've joined us now. Lots of lovely comments about your project, you'll be glad to know as well. So we're getting as many comments and questions that you've got at home as you can. Put them either on the BATC streamer or on Zoom, and I'll try and get them all to Michael. I've just got one quick question. Can I ask you first, though, Michael? How long have you been working on this project?
Oh, not long. I can't remember actually, but maybe 2 months or maybe 3 when I started. I only discovered DATV by accident, actually. I mean, I am an amateur, not very active, I have to say, but I'm not into this 5 and 9 stuff, contesting and all that. And I'd really like to talk to people that speak English. But propagation into England, well, it's not the propagation, it's the interference that people in England have, their local noise levels. There's not that many opportunities. I can reach the north of, very top of Scotland very well. I can get into North Wales very well. And I can get onto the right at the south of England. But the middle bits, Lancashire, Yorkshire, which is, I'm from Yorkshire, Zilch, actually. Now, I just don't think people are using it. I think everyone's on VHF or something. I don't know what's going on.
It's a perfect reason to go to satellite and things like that, isn't it?
Yeah,
we've got a few comments for you and questions. Yanis YL3AKC says, really interesting, logical and easy to use control interface. Is there more information like web links for your project? Or I'll add a little PS to that. If there isn't, would you consider maybe sharing them with the BATC, that we could share them with others?
Well, yes, I do intend to share it. And in fact, I've already got a GitHub page, but there's no code on there yet. There's no point because it's pretty useless to anyone unless they're really committed. They would certainly have to have a Pi, and you've got to use both together. So you could download the desktop version as it is now, but I really can't see the point in that because none of the buttons are going to do anything. It's got to be connected to a Pi. But there is a GitHub page, but all there is at the moment is a couple of README files, one for the server and one for the client. The client's called, what's the client called? SAT controller, and the server's called SAT server original.
No, they're great. I mean, they're obvious, and so you don't have to think what they mean. Would you do us a favour and let us know, BATC know, when you've put them up there, because I'm sure we'd love to share them with the wider audience of the wider community.
Soon, actually. I mean, doing this presentation and the fact that my partner Pilar insisted on going on holiday a few weeks ago has really stopped things happening, really. So software development, apart from a little bit of panic software, I mean, for example, this colour bar thing that across the top, I only put that in last week when I started to make the presentation. And that delayed making the presentation, which threw me into a total panic, thinking I wouldn't get it done in time and so on. So I've got quite a bit of hardware now. It's all in that cupboard wardrobe behind me, actually. The only thing I'm really waiting for, and it's stuck in customs, thank you to all those people that voted Brexit.
Oh, let's not get political.
No, sorry. But it really is causing problems on both sides. I mean, we've seen what's on the news. And the strange thing is Amazon can get things. I mean, I ordered something from Amazon UK and it arrived in 3 days.
I suspect it's because they're going to use their own infrastructure, isn't it?
But I presume they seem to be bypassing customs somehow. I don't know why.
Well, anyway, let's get back to the questions. I don't want to miss anybody's questions for you, if that's all right. So Dave GKQ says, what transmit software do you plan to use to drive the Pluto?
To drive the Pluto? Well, it's going to be... I mean, that's a good question, isn't it? I'm going to write it myself. I've got the infrastructure into the server. The server, when you press transmit, it's already spewing out a text line, which is the one you send to the Pluto to set up the frequency. I can't remember what it's called now. You send it over the internet anyhow. So the Pluto will be connected to the server, and you just send it a command string, and that sets up the channels and frequencies and symbol rates and things like that in one string, and also activates, I believe it, I'm not quite sure about the press to talk actually, I haven't really gone too far into that at the moment because I know it's going to work. It's just that the details, I've got to study other people's source code to find out, because unless somebody's documented how to talk to a Pluto in a nice PDF document, that would be marvellous. Otherwise, I have to go through other people's software, Dave's software, for example, to see how it's done, which is very time consuming. So it's possible.
Okay.
Did that answer the question?
Yeah, that's fine. Thank you. I've got a few little comments there, but you'll be glad to know it's not just you and me into Macs, because Mike M0XXM says, well done, Michael. Very interesting and nice to see development for Macs. Chris G0DAE says also, will there be a release of your software on the Mac platform? I guess you said that you were going to be sharing it. And Chris G0DAE says, will there be a release of your software on the Mac platform? So several people asking there. Oh, and also another one, John G8PF, yes sir, +1 for the Mac element for me too, although I've had to relent and buy a Windows machine recently, he says. So anyway, but there are more than two of us. Mike G0MJW says the Pluto with F5 OEO firmware does not need transmit software, only a transport stream and commands, and he says that the instructions are available within the firmware's built-in web server.
Oh, okay. Well, as I say, the Pluto only arrived this week actually, and I haven't looked into that at all. But yeah, if that's on the Pluto's wiki, that's fantastic. That would be very helpful. Thank you very much for that. Yeah.
Okay. Dave comes back and asks another question. How will you interface the Swift software to the transmit software? Have you worked that out yet?
Well, I'm using Swift on the server and on the client, and that's very handy because I only have to concentrate on one language, and that's one of the reasons for choosing Swift, because it's open source and it works on both. By the way, the Swift is running on the 64-bit beta release of whatever it's called, Buster, or whatever the latest one is, which will presumably be the next release. And it's absolutely perfect. There's nothing wrong with that. I'm using the light version because I don't need the desktop version. I'm using the light version, and it works. The only things that don't work are some of the Python scripts for other things that people have done. You know, they've got to port all the little packages over before they release it. But the operating system's finished, so that's stable. Whether it needs 64-bit, I don't know, but it seems like a good idea to me. It's stable. The server, I got that working, and I just leave it on 24/7. You know, and I really hammer it during testing. And it just doesn't blink. You know, it's using about 2% of the processing power. It's very, very efficient.
Excellent, thank you. Phil M0PIT has a comment and says, I've been working on an Arduino-based remote hardware controller with power supply and RF level monitoring that use a web interface, and hopefully I'll make the code also available in the next 3 months.
Excellent.
So you're inspiring lots of others, I'm sure, to do this. Mike?
Well, I'd like to inspire other people to consider using Macs because, you know, let me just tell you, a Mac is a Unix computer, okay? It's Unix. And the only thing that makes it Mac is the GUI, the user interface, the GUI. Now, if you use Unix, Linux, you know, you've got so many choices of user interfaces, you'd spend all your life trying to decide which is a nice one. With Apple, you don't have a choice, and it just works. And after all the Linux ones, they're all trying to copy either Windows or they're trying to copy Macs. So why not just get a Mac?
Do you know what? You sound just like I do with some of my friends sometimes, although it's a bit easier now than it was about 10, 15 years ago when everybody couldn't not see the point in me loving Macs. But anyway, we better not get onto Mac versus PC argument, or we'll take up the whole day with that, I think. What have I got? Something else here, I think. Mike G0MJW came back and said it's not on the Pluto wiki, but it is on the BATC wiki. And okay. And Noel has actually put a comment. Noel from BATC says anyone would think it's a religion. Yes, I know what it means. So let's avoid that. But you did share with me when we met earlier in the week for a rehearsal that you used to work for ITV in the UK and things. So how similar was this to your job that you did there? Were you doing coding and things like that then?
No. Coding's always been a hobby. I got interested in computers when they first became available for the public, I think the first one I bought, people were buying Sinclairs and things like that then, but I bought the Commodore PET. Is that what it was called? Something like that.
Yeah, the old-fashioned little sitting space age looking thing. Yeah.
And I had it on order. I think I got the second one that came into the country, or the third one, And I bought a book on BASIC, and a very simple book, and started from there. And then I graduated then to I bought a North Star Horizon. You can find that on the internet.
Yeah, I remember that in the 80s, wasn't it?
Yeah, something like that.
Yeah.
Nice wooden box, and it was an S100 computer. And you had to buy S100 cards, and I bought a graphics card for it, which cost something like £1,000 or something. And I know you can pay that these days, but this only did 40 by 20. And I wrote Prestel on that. I wrote a Prestel emulator on that, and I took it to a software, an IBM software house in Otley where I lived. My wife worked there at the time, and I showed it to the man that ran this company. They wrote software for System 36 IBM computers, and they bought it off me. They paid me £2,000.
Well, that paid for your graphics card and £1,000 profit.
Yeah.
Well, that's really good. That's fantastic. And I don't know if you're like me. I mean, I was brought up in as well in those early 80s days of the home computer, the ZX81 and things, which introduced so many people to coding at home. And then it all felt that we couldn't do anything like that. But I think things like the Raspberry Pi, the Arduino, those have really brought it back, into something that is made it accessible to all of us enthusiasts.
Well, the problem we're in now, we're in this, selfie era that we live in. I'm 75, I'll admit it, I'm grumpy. But, desktops are not fashionable. And, Apple are the same. It's iPhone. That's all they think about. And they've released the new operating system, which will have an update to the Swift UI in it, which I need, because I've got memory deallocation problems, actually, which are not my fault, they're the compiler's fault. Well, they released it for the iOS market, a few weeks ago. I'm still waiting for the desktop. So, we're in a minority, people that use desktops now, and it's not going to get easier. It really isn't.
No, and I think both on the Mac and the Windows side, they are gradually coming together. Windows, a tablet, become a computer. You add a keyboard to it, and and I've got a comment here from Yanis YR3AKC. He just came back and said, "I'm looking on Micheal and can see his future. I'm also working on television, coding, Linux, Unix, and soldering as a hobby as well." So, and I'm sure lots of people watching are doing the same. Micheal, it's been a pleasure to meet you, and thank you very much for sharing your project. I hope you'll continue to share it. And
I will.
As I said, please do let Dave and Noel and the BATC know when you sort of publish this, because it would be great to share it with other people.
Well, I am absolutely going to share it. And one of the reasons for doing this presentation is that if there's anybody out there that would like to collaborate with me, I had a PM from Tim the other day, because I'm like this about whether to use the advanced receiver or RIDE, and I don't know enough about either of them at the moment. And he actually said, if there's anything you want adding, just ask me. But he's got a list this long, so I don't know if he'd be able to cope. The advanced receiver looks attractive. In fact, I bought the PCB card, but I haven't actually ordered the components yet, so it's still in the air, is that one. I'll probably finish up building both, won't I? So that's it. Yeah.
Well, no, it's been.
I do have a website actually.
Have you got the web address?
Yeah, it's michaelnaylor.es.
So it's Micheal Naylor, all one word, .es.
And on that you'll find links to my GitHub, links to Swift forums, things like that, and a little bit about me. In fact, it's mainly about me.
No, well, it's really interesting, Micheal. Thank you ever so much. As I said, you've inspired many of us to give it a go ourselves and have a go at coding. Thank you very much for joining us on the Cat 21 convention.
Thank you very much for having me. Thank you.
Thank you, Micheal.